Hello everyone, I'm Mustafa Berk Elkar. I'm a senior student at Hacettepe University Electrical and Electronics Engineering Department. Together with my friend Burak Demirbüken, we will present our graduation project to you. Our project is horn antenna design for Cubant application using 3D printer. Although there are manufacturers in the market where we can buy horn antennas, the prices of these antennas are very high. In addition to the expensiveness of these antennas, only some manufacturers produce antennas according to your demands, while others only sell antennas that they produce as standard. The main purpose of our project is to produce an antenna with the features we want, quickly and cost effectively. Our project basically consists of two parts. The first part is the production of the antenna design according to the desired features. The second part is to cover the produced antenna with a conductive material that will make it work. Before moving on to solution methodology, I would like to tell you a little about the applications areas of the horn antenna. The horn antenna is widely used as a feed element for large radio astronomy, satellite tracking, and communication dishes found installed throughout the world. In addition to its utility as a feed for reflectors and lenses, it's a common element of the phased arrays and serves as a universal standard for calibration and gain measurements of other high-gain antennas. Its widespread applicability stems from its simplicity in construction, ease of excitation, versatility, large gain, and preferred overall performance.
Hello, I'm Burak Demirbüken. I will talk about the solution methodology of our project. The first part of our project starts with antenna design. So we started by reading books and articles on how to design a horn antenna. But in our later research, we found tools that give you the necessary antenna dimensions depending on your demands when you enter the desired gain and operating frequency. In other words, antenna sizes that operate at the desired frequency and have a desired gain value can be found even without knowing how the antenna design is made. Later in this part of our project, by taking into account the recommendation of our advisor, we decided to use the dimensions of antenna of a vector telecom company with a 15 dB gain value. After determining the dimensions of the antenna we will use in production, it was time to choose the material we will use for metal coating. There were many options for metal coating, such as conductive filament, conductive paint, conductive plate, and conductive tape. We preferred to use aluminum tape for reasons such as being accessible, inexpensive, and easy to apply. We used the CST Microwave Studio for simulation, and we simulated our antenna whose dimensions and material were decided before, using this program. As a result of the simulation, the S parameter of the antenna was minus 55 dB at the desired operating frequency. Since we thought that the simulation results were suitable for our demands, we decided to produce this antenna and fabricate it using 3D printer and ABS filaments. After obtaining the skeleton of the antenna, we covered the necessary parts with metal using aluminum tape. After our antenna took its final form, we tested it in the antenna laboratory in our department, and the S parameter graph came out as in the figure. As seen in the figure, the S parameter of the antenna was minus 27 dB at the desired operating frequency and below minus 55 dB at all other frequencies. We would like to thank the Professor Dr. Birsen Saka for all her contributions throughout the project. Thanks for listening.